Thank you for joining this lesson. Remember to subscribe to our channel and to also share the link with your friends. So we're going to consider the KCC 2016 paper, a question in calculus, a differentiation question number 10, where we are told that the gradient of the tangent to the curve y equals to ax power 3 plus bx at the point 1, 1 is negative 5. Calculate the values of a and b. So for us to calculate the values of a and b, we should first of all understand this question. Because there is already a provided coordinate, then we can come up with several equations, and the first one will follow this coordinate because we have the value of x and that of y. Then we can say, according to this equation which relates y and x, then we can have a 1 in the place of x and 1 in the place of y, so that following this equation we come up with one equation. If x equals to 1 when y is 1, then we can say y equals to 1, which is equal to a multiplied by x, which is 1 cubed, plus b multiplied by x, which is 1. So this means we can have 1 equals to 1 power 3 is 1, so this becomes a, plus 1 times b is just b, so we can call this one equation 1. And we proceed to get another equation. We are talking of the gradient to the tangent. So if we have gradient to the tangent, then it means gradient to the tangent is also gradient to the curve at the same point. So what we should do at this point is we first of all obtain what we are calling the gradient function. And the gradient function is the derivative of y with respect to x. So dy dx gives us the gradient function. When we derive this function, we drop power 3 here, so that we get 3a multiplied by x, but x now becomes squared. Then plus b times x, x is to power 1, so we drop 1, and x becomes power 0, and power 0 makes it 1. So we just remain with b at this point. Now we are saying at the same coordinate, the value of gradient is negative 5. So we'll say the value of dy dx equals to negative 5. So that's negative 5 equals to 3 multiplied by a, and the value of x at that point squared, then plus b. So this means we can obtain a second equation by saying negative 5 equals to 3a, because when we square 1, it remains 1 times 3a. We get 3a plus b. So we got a second equation here. So the two equations now can be solved simultaneously to give us the values of a and b. From equation 1, we can say the value of a equals to 1 minus b, because to remain with a we have to take b to the other side, 1 minus b, so that in the second equation now, wherever we have a, we substitute with 1 minus b. Negative 5 is equal to 3 times a, 1 minus b, then plus b. So here we shall have negative 5 equals to 3, then negative 3b plus b. So that after grouping like terms together, we shall have 3 coming to this side becomes negative. So you have negative 8 equals to negative 3b plus b, negative 2b. So that to remain with b, we divide through by negative 2, and the negatives cancel one another, and the value of b is going to be 4. So that after getting the value of b as 4, then we will say a equals to 1 minus the value of b according to this equation here. So a equals to negative 3.